So now going into the decision trees. Now we have already learned the decision tree classification, and we'll have a recap on that, and we'll go into the practical experimentation on the decision tree learning. Right. So that's the agenda of today's thing. Now we know that decision tree learning. Right. If you remember anything about decision tree learning, you just enumerate here. The same point I'm going to discuss with some extra points out also. Right. In decision trees, how the data should be there. Do you remember this A comma V pairs? What is A comma V pair? Shall I say it as attribute value pair? Do you remember this? I want everyone to please be unmuted. I want everyone to be unmuted. Do you remember? For in the decision trees, input should be attribute value comma value pairs. Attribute comma value pairs. Any other thing you remember about decision trees? Like in decision trees, can I give outlier data or only good data should be given? What is the efficiency of decision trees?
Outliers also you can give.
Outlier data. That is actually special features. If the data is having
Decision trees and AB scan.
missing values, if the data is having outliers or noise generally, decision tree can be used because they have an important criterion to check the impurity in the data, and that we actually call it as
Entropy.
entropy. Yes, very good. That is used to record our impurity in the data. And what will be the purity or the essential characteristics of the data recommended by?
Information gain.
We saw something called as information gain. That will say yes, it will be the purity in the data. So that is the information gain. So these two metrics we actually use, and we have the formulae also for doing the same. For example, if it is going to be an entropy kind of thing, I can say that entropy of a particular set S. Say it is going to be an overall output probability. If I want to say the entropy, what is the formula? Minus P
Minus P
or
plus
minus P
log 2 P
positive.
plus
Yes, minus P positive log base to P positive minus P
P
negative
negative.
log base to P negative. Yes. Minus P negative log base to P negative. So this is actually the formula for entropy we actually see. And we know that entropy actually ranges between 0 to 1. Entropy actually ranges from 0 to 1. And a simple question if I want to ask, if all the data belong to either positive class or negative class, then what will be the entropy? That is, if I have a number of yes and number of no, if all are yes and only positive data exists and there is no negative data, then what will be the entropy value? 0 or 1?
Zeros.
Yes. How?
Sir, because in entropy there is a graph, sir. In entropy graph, if it is
Great.
and it will be
Yes.
0
So
and gene impurity will be 0.5.
yes. So now in P positive, if it is only present in the positive index and in negative index, I have 0. Or in other case, if I have all the sets to be negative and the positive index becomes 0, then it means that there is no decision to be taken because everything is positive or everything is negative. So we say that there is 0 impurity in the data. So easily I can take a decision. While in the other end, if in both the sides I have equal data, so if in both the sides I can have equal data, then my entropy value will be 1. So this 0 actually says what is, I'll take this paint. 0 says that if data is present only in one class, either positive fully or negative fully, then we say that it is going to be 0 because there is no impurity in the 0, 0 impurity I say. So it is easy to classify also. That is actually the thing over this 0 record. On the other hand, if it is 1, if data is equally present in positive and negative distributions, right, negative cases, then I say that my entropy value will be 1. Otherwise, it will range in between 0 and 1. So this is with respect to entropy. So on the whole, if we need to put out what actually entropy is, if I want to take some particular data set and I want to take a decision on how I need to travel along the decision tree, then I can just take the entropy and check how much impurity is there in this particular set. Impurities doesn't mean that noise or outliers. It means that how much difficult it is going to take a decision with this available set S, with this particular attribute S, how much difficulty is being involved. If it is everything is positive, then I can say whatever data comes, I can just say positive. If everything is negative, I can directly say whatever comes, I just say the answer negative. Else, what will happen? I need to do some other analysis and say whether it is positive or negative. So, as entropy increases, say that impurity increases, and it will be difficult to take a decision. So, I put a point here. As entropy increases, what will happen is the difficulty in taking decisions increase. So we should have as low entropy as possible. Otherwise, we need that you there is no way to take in the particular data. So this is actually the case with respect to entropy, right? We care about the entropy. You already know this. Yes, we proceed into the information gain as in Gini chart. Yes. Now going into the information gain again. When my data is having more information, then it is easy for me to calculate, say whether this particular output is correct or wrong. So how much support that attribute A can give to S, that actually I say is an information gain. Right? In this information gain is obtained with a very easy way. That is, you calculate the total entropy and subtract it by the entropy of each individual values in the taken attribute. That is what the information gain. We have another attribute as in initial then beginning again the said we have another metric, that is Gini, right? This Gini is also an efficient metric that is used to say how much pure or how much impure my division is going to be there. There is actually a relationship between this entropy as well as a Gini. You can evident that by seeing the formula of Gini, that is 1 minus summation Pn, the whole square. Yes, I can range from I is equal to 1 to n. That is the number of attributes I have actually. So I is equal to 1 to n. So this Pi is actually represent the classes. If it is only positive and negative class, then only P positive and P negative alone will be there. Else it will be going to a wide range. If I want to write entropy for the same thing, for entropy also I can write in Pi terms as E of S is equal to minus summation Pi log base to Pi. So this is actually the formula for entropy. So here the only difference is I have taken here Pi squared and I taken 1 minus this, and this is actually Pi log base to Pi. The variance over here, both of them are going to say me how my split decision is going to be there. This actually ranges from 0 to 1. Why? Because it is having a support from logarithm that ranges from 0 to 1. Gini, as you can already said, it is going to range from 0 to 0.5. So this is actually the range for Gini. Now, both are being an impurity metric, which metric we have to use? So this will be an actual question whether this is good or this is good. In any way, I can actually find how impure my data is or how much a split decision I can actually take. Right here also 0 means good, and here also 0 means good, and as it increases the value actually says that my data is not that much pure to take decisions. Now which should be selected? That will be a most important question, right?
Sir,
So
gene impurity, sir.
yes, yes, it is not that always we should select Guinea impurity. There is a way to select when to use Guinea impurity. If you see here for Guinea impurity, it ranges actually between 0 to 0.5 alone, whereas entropy actually ranges from 0 to 1. If you have computational power sufficient, if sufficient computational power is there, then you can easily go for entropy and solve your data. That is, if you have sufficient computational power. You can ask me a thing that why a machine learning algorithm requires that much computational power? It is already running on a big machine. This is not a case. Why? Because we run several iterations for the same algorithm itself. So how much computation it will actually do, we actually don't know, because it may run for several iterations. So if you see that only few iterations are going to be there, then then computational power doesn't matter. Otherwise, you need sufficient computational power to make your algorithm run good. So entropy requires computational power because it has some higher value. Say if 0.9 and all is there, his multiplication and divisions may become more complex. Whereas if computation power is less in your system, then you can use Gini metric. That is actually the difference. Both are essentially going to give some same value. To be more clear, if I give an example here, if entropy is going to take some value like 0.65, at the same time, Gini will take a value as 0.3. At the same time, Gini will take some value as 0.3. Approximately. Why? Because this is actually the highest here. If it is 1 means here it means 0.5. So the value actually ranges between that. If you say something like 0.65 impure, then it is actually somewhat impure only. Then here I mean it is going to be 0.3. Anyway, it is understood by the system and how I need to make a split. I'll be having some root, and for this root I'll be taking an entropy record, and based on that I'll be doing a split. So how much efficient I can do this split can be determined through this entropy. So whether I can proceed or not, I can use the to take that decision. I can use gain. But how much efficient this split is going to be there is going to be judged by the entropy criteria. So this is actually the case, right? So this is actually the Gini metric and entropy. To be in particular points of consideration, you remember the formula for entropy, information gain, and Gini, as well as the range for entropy as well as the Gini. These things you actually remember. And what essentially the difference between a Gini metric and entropy metric. Another case in which we have to use Gini is if you are going to use your decision tree metric for regression purposes, then purely you'll be using Gini metric. We know that the decision tree metric is not only used for classification, but we are intended to learn it for classification. But decision tree can also do regression activities. So Gini will be helpful when you do regression things with decision trees. If you want to do decision tree for regression, then you can actually use Gini metric. So these are the things you need to remember, right? Yes. So I will finish out this theory session with 4 questions. Question number 1. Yes. Can decision tree be used for only classification or regression or both?
Both.
Both.
Yes. Not only again that I'm asking to everyone. Yes. Thank you, everyone. Yes. Second question. What is the range for Gini metric?
0 to 0.5.
Great. 0 to
1.
0.5. Now, if I say a particular metric to take a particular data set to take Gini, then what might be the reason? Say, for example, it is going to be used for classification. Option 2, it is going to be used for regression. Option
For
3, computational power is not available. So for third, both B and C.
Both B and C.
Yes, both B and
both
C in
B
the
and
sense it is going to be used for regression, or it we need to do in more compact fashion with less time complexity. Third one, if I have something like entropy, right? If both the values in both, sorry, if I have only 2 classes, and in 2 classes I have data equally divided, then what will be the entropy value?
One.
0, 1 or 0.5 or
Mm.
something else.
1, sir.
1, sir. 1. If it is equally divided, it will be 1. Final question. If I ask any formula for either entropy or information gain, shall you say? Or say, for example, information gain. Can you say the formula for information gain? Information gain formula? Very simple, right? Entropy of S minus summation V belongs to value of A.
Entropy of S minus summation V belongs to values and entropy and subset after splitting by entropy into entropy of summation subset after splitting.
Okay. It is not, you don't want to say it is splitting. It is just the values in that particular attribute. For example, if I have several values for this attribute, then for each attribute, I have to do that particular selection. There is no splitting that is going to come here. Based on that gain only, I'm going to select an attribute, and splitting is going to happen based on the individual entropy values, right? So this is fine. Let me go into the practical session on this. Let me just clear it out. Sorry, if you want to take screenshot, you can take. That will be better. Yes. Shall I erase this?
Yes, sir.
Yes. Thank you. So remember the range values, everything that because that and all will be available only when I take classes. I don't know whether in IBM PPT it is available or not. Now going into the decision trees, right? I just took some random data set to make decision trees more clear. I don't know whether the data set is correct or not. I just considered we actually tried for one of Tamil movie last in AML. Since I don't know much about RRR, but I have seen many posters of RRR in status. So based on that, I gave something. Don't think that I thought it as a comedy movie. Just I added this. If it is wrong, please pardon me. Okay. So the features what I take for the RRR movie to become hit or flop is comedy strength, action scene, aggression, and state. In which state, if it is released, it will be more hit like that, right? So as you know, that comedy strength can have values like highly comedy, low comedy, and there is something called as satire comedy. I don't know whether in Andhra it is available or not. Whether satire comedy is available in Andhra? What is satire comedy in the sense there will be a person coming who will make other person to become as low as possible. He will be making the other person more low and making everyone laugh. So, but the person who is actually taking that will be feeling more shy. That kind of comedy will be there in Andhra or not? Yes. So that is actually called a satire comedy. We actually many people will not like that kind of comedies because the person who is being used for making comedy will be feeling more. So we don't like satires. Somebody, right? So this is actually the case. And action scenes. I kept some action scenes like 19. Why? Because the poster actually looks like that. I think the entire 3 hours is going to be action scene. I hope. I don't know much about it. So I keep some action scenes as 19 and 16 and all. And aggression. This also by seeing that horses and bikes and all, I kept some aggression rate for this. How many aggressions are actually being happening? So that's the thing. And that movie may be released all over India, but I have kept it here 4 states: AP, Tamil Nadu, Kerala, and Karnataka. So these are the things actually present here, right? Now I ask you 3 questions. Question number 1: if I was going to do a classification, discrete or continuous? If I want to do classification, yes. If I want to do a classification task, whether I need to have my output variable as discrete variable or continuous variable? Yes. Now coming into this thing, I repeat the same question. If it is a decision tree kind of thing, whether my output variable should be discrete or continuous?
Discrete, sir.
Discrete.
Discrete,
Yes.
sir.
Either 0 or 1, hit, flap, true, false, like that. So my data set is suitable for classification. Now, similarly, in decision trees, we need data in such a way that it should be in attribute value pairs. Now, I have comedy strength as an attribute whose values are high, satire, low. Action scene is an attribute whose value is 11, 10, 6, like that. Aggression is there 4, 5, 6, and state is AP like this. Now we have something like action, scene, aggression. These values are there, and comedy strength is there. Now, can I give non-numerical data to decision trees so that it will classify better? Can I give non-numerical data? Because we know that all machine learning algorithms, when I run it in a system, we need to convert it into numerics. So we can actually convert it into like hit means one, flap means zero, like that. I can do a conversion so that it will work finally with respect to those binaries, discrete items. So what I actually do is I import pandas for uploading my data set, that is RRR movie. Then I import sklearn. From sklearn I import the tree, and this tree is actually having many tree algorithms starting from decision trees, random forest, and many other tree algorithms are actually being present here. Next I use pi dot plus. This pi dot plus is actually used to make my decision tree image to get saved, and in this matplot image also I want my image to get saved, and this plot is for plotting my accuracies and so on. And from this sklearn.tree I take the decision tree classifier. Now I using pandas the same way. I upload the RRR movie into my data frame df, and I print the data set. It is having chul records. It's very small data set created, right? Now I need to convert these things into numerical items. So what I actually do, I actually create a variables commodity strength as cs. High means low. I create a dictionary, high to 0, satire to 1, and low to 2. Then what I do in the df, that is in my data frame, the comedy strength attribute should be mapped with the cs value. So df comedy strength dot map of cs. So what will actually happen is all the high will be mapped to 0. All the satire will be mapped to 1, and all low will be mapped to 2. This is what will happen with respect to this mapping kind, right? Similarly, I take state AP to 0, TN to 1, KLA, that is Kerala to 2, and KNT, Karnataka to 3. And just I map the state. Similarly, I do hit as 1 and flap as 0, right? And I'm making this conversion from categorical data to numerical zeros and 1 discrete values. Clear? Am I making it clear?
Yes, sir.
Yes.
Yes, sir.
Now I have these values. Everything is actually changed. If you see zeros and zeros in the first three columns, if you see it's high, satire, and low. So 0, 1, 0, it came. So all the values is actually mapped to some numerical fields. Now I can go and apply my what is my input and what is my output. So I take my features: comedy strength, action, scene, aggression, and state. These are going to be my attributes as input X, and output is going to be RRR, that is the film is going to be hit or flap. So I just print an X and Y and see what are the inputs and outputs. So I have my inputs and outputs ready. So this is actually the initial phase. Next, what I do, I just use my decision trees and fit my algorithm. I take D tree is equal to decision tree classifier of. So all the machine learning algorithms will essentially have the same methods. Like you use linear regression of, then linear regression dot fit, logistic regression of logistic regression dot fit. Nearest neighbor also the same thing. Everything is just call the particular method and fit it. The thing is, first we need to theoretically understand the mathematical background and then come into this programming, right? But in a practical, it is very simple, just to do a fitting, right? That is what they actually expect in industry also. They want it to be practical ML. Background also will be useful, but only up to the interview level. But they say when they say yesterday, they say a practical machine learning person is like that, right? Now, so I say d3 dot fit of x comma y. X is going to be my input and y is my output. Then what I do, I have my data is equal to tree dot export underscore graphs. Now what I'm going to do is I'm going to print the entire decision tree. When we do it in pen and paper, we will be finding what is the root or what is the best attribute, like that we will be doing for to be in the root. Here we can actually print and see the entire decision tree itself. So I can make the D tree should be happen. The D tree is having the tree. My output I don't keep any name to my output file, and feature names will be features. Or I have my features available. That is comedy strength, action scene, aggression, and state. I use that, right? Now graph is equal to pi dot plus dot graph from data dot data. to data, then what I'm going to do is I'm going to copy it to my image file. I'm going to create an image file and to copy the entire decision tree to that, and I write it to the decision tree. Right, my the output file is present in decision tree underscore rrr.png. Next, what I do, I plot this image in this output screen by using that matplotlib, and I get something like this. I'll open this to, so I'll zoom it somewhat. Let me run it one more time to make it zoomed. Yes, I can go here and take that particular decision tree. Close this. I minimize this also. Yes. So what is the key attribute here? The key attribute here is going to be action scene, and it itself is actually discretizing it. How the discretizing value is? It takes 10.5 as a threshold. If it is less than or equal to 10.5, then it is great. And see the Guinea value. Guinea value is equal to 0.473 because it is having that much impurity also. It is manually created data set, so surely it will have more noise. And Guinea says that it is 0.4, closer to 0.5 actually. And number of samples 13, we know that. And values, positive class is going to be 5 and negative class is 8 with respect to the action scene. So 8 times it became flat, so we don't want that much action scene, I hope. uh, Sorry, if it is less than or equal to 10.5, it is flat, so we require more action scene, it seems. Next, state. State also, 0 corresponds to AP, 1 corresponds to TN, and 2 corresponds to Kerala, and 3 corresponds to Karnataka. So in almost AP, TN, and Kerala, we can say that it is going to be somewhat hit. So it is over here, and Guinea is also higher here. And next we go down. Again, we have actions seen to be taken into consideration. Actions in that particular state we can have less than or equal to 5.5, and that is the rate here. And here also again state. So there is no room for taking into account the comedy strength up to this level. Finally came the comedy strength. So it means that movies hit or flap is not going to be uh, done by using the comedy strength. It is only with respect to the action stream as well as the state. And if you see aggression is not present anywhere, means that it is actually very low. So it is not very much involved in predicting the hit or flap of a particular movie. So this is the decision tree classification example, right? I am making it clear. I am making it clear the decision tree, both the theory as well as the practical.
Yes, sir.
Yes. So what we'll actually do is I'll post this in our Google Classroom. In the coming practical session, we'll be seeing how as usual, the ESPN cricket data as per our lab, how we can actually classify that with respect to decision trees. But the problem statement in the next exercise of decision trees is somewhat more complex. That is predicting the match outcome. That is either win or loss by using decision trees. It will be somewhat in a higher class. We will see how to make it as simple as possible and solve the same. Right? Yes. So this is with respect to the decision trees.